The wind in the Crimean mountains does not simply blow, it bites. On the night of November 2nd, 2025, the air at the Margot Observatory in Nauchnai was thin and sharp enough to freeze the breath in a man's throat. It was a silence so deep that it felt heavy, broken only by the rhythmic creaking of pine trees and the soft electric hum of a cooling fan attached to a camera sensor. Far below, the world was asleep. Cities were just glowing patches of orange light on the horizon, ignorant and safe. But up here, at an altitude of 600 meters, the world was not safe. It was exposed. The sky above was a vast, open ocean of darkness, and down on the ground, a single man was fishing in it. His name was Gennady Borisov. He did not look like a guardian of humanity. He wore a thick, worn-out coat that had seen too many winters and a knitted hat pulled low over his ears. His hands were rough-stained with machine oil and the dust of grinding mirrors. He was not sitting in a heated control room surrounded by walls of monitors like the scientists at NASA or the European Space Agency. He was standing in the cold in a small white shed with a sliding roof that he had built himself. In the center of the shed stood his weapon, a telescope. It was not a sleek, factory-made machine. It was a beast of carbon fiber and metal cobbled together in his own workshop. To the untrained eye, it looked like a strange cannon pointing at the stars, but to Gennady it was a masterpiece. He had ground the mirrors himself, checking the curve to a fraction of a millimeter. He had welded the frame. He knew every vibration, every quirk, and every sound this machine made. While the governments of the world spent billions of dollars on automated systems to scan the sky, Gennady trusted his own hands. The time was 3 o'clock in the morning. Gennady rubbed his gloved hands together to keep the blood flowing. He looked at the computer screen connected to the telescope. The screen showed a field of stars, static white dots against a black background. Most people would see nothing but noise. Gennady saw a map. He knew these stars better than he knew the streets of his own town. He was scanning a sector of the sky close to the horizon. This was the dangerous place, the blind spot. The big billion-dollar robotic telescopes in Hawaii and Chile usually avoided looking too close to the horizon because the atmosphere was thick and the light from the rising or setting sun could interfere with their sensors. They liked the easy, clear sky straight up, but Gennady liked the difficult places. He knew that if something were to sneak up on Earth, it would come from the shadows where no one else was looking. The software on his computer beeped. It was a soft, dull sound indicating that the camera had detected movement. Gennady leaned in, squinting at the pixelated image. The software compared 3 photos taken a few minutes apart. If a star was real, it stayed in the same place. If a dot moved, it was something else, an asteroid, a comet, or a piece of space junk. There was a dot. It was faint, barely visible, hovering at around magnitude 19. "Hello there," he whispered. In Russian, his voice raspy from the cold. He watched the dot jump from the first frame to the second and then to the third. His heart gave a strange, uncomfortable thump. It was fast, too fast. Usually asteroids in the main belt, which sits between Mars and Jupiter, move slowly across the screen. Near-Earth objects move faster. But this object was tearing through the starfield like a bullet. The speed suggested it was incredibly close to Earth. Gennady frowned. He opened a second window on his laptop. He accessed the database of the Minor Planet Center. This was the global registry for everything flying in space. If a rock was out there and it was this bright and this fast, the big surveys like Pan-STARRS or Atlas should have found it weeks ago. They had algorithms running 24 hours a day to catch things like this. He typed in the coordinates. He waited for the database to return a match. No known object found. He tried again, widening the search parameters. No known object found. The cold air suddenly felt much colder. Gennady sat back in his chair. He looked from the screen to the open roof, staring up at the actual stars with his naked eyes. This was impossible. An object moving at this speed, at this brightness, could not just appear out of nowhere. It meant one of two things. Either the object had just emerged from behind the sun, blinding the sensors until the very last moment, or it had come from a trajectory so strange, so steep, that the mathematical models of the automated systems had simply filtered it out as a glitch. It was a rock the size of a football stadium, and it had slipped past the most advanced surveillance shield in human history. It had walked right through the front door, and the only person who saw it was a man in a shed in Crimea with a homemade telescope. He needed to calculate the orbit. He took more images. Click, wait, click, wait. 40 minutes passed. With 4 clear positions, he could run a rough calculation of its path. He entered the numbers into his software. The lines on the graph curved and intersected. When the result appeared, Gennady stopped breathing for a moment. The eccentricity of the orbit was wrong. A normal orbit around the Sun is a circle or an oval. This corresponds to an eccentricity between 0 and 1. If the number is greater than 1, it means the object is not orbiting the Sun at all. It means it is a visitor. It comes from deep space, passes through, and leaves. The screen read eccentricity equals 1.04. It was hyperbolic. Interstellar. Memories flooded back to him. The year 2019. He had been standing in this same spot using a smaller telescope. That night he had found a comet that shocked the world. They named it 2I Borisov. It was the first rogue comet ever detected passing through our solar system. It had made him famous. Interviews, articles, handshakes. But that comet had been far away, millions of kilometers away. It was a curiosity, a scientific marvel. This new object was different. The distance data on his screen was dropping rapidly. It wasn't just passing through the neighborhood. It was skimming the atmosphere. It was coming incredibly close to the Earth-Moon system. He looked at the object again. It had no tail. It wasn't a fuzzy comet like the one he found in 2019. It was a solid dark rock, an asteroid, an interstellar asteroid. He realized the irony of the situation. The world had spent the last 6 years building better planetary defense systems. They had launched satellites. They had discussed gravity tractors and kinetic impactors to deflect asteroids. They patted themselves on the back, believing they were watching every angle. And yet here was the truth. The sky is too big. Machines only look where they are told to look. They lack intuition. They lack the hunter's instinct. Gennady began typing his report to the Minor Planet Center. His fingers were stiff, but he typed with the steady rhythm of a professional. He had to be fast. Other astronomers needed to confirm this before the sun rose and hid the object in the glare of daylight. He filled in the observer field G. Borisov. He paused at that line. The world would see that name again. They would say, him again, how does he do it? They would call him a genius or a wizard. But Gennady knew the truth. It wasn't magic. It was patience. It was the willingness to stand in the freezing cold when everyone else was warm in bed. It was the humility to understand that the universe does not care about human technology. The universe is vast, dark, and full of surprises, and it only reveals its secrets to those who truly watch. He hit send. The data packet traveled through the internet cables down the mountain across the ocean to a server in Massachusetts. Gennady stood up and walked to the opening of the roof. He looked up at the patch of sky where the object was moving. He couldn't see it with his eyes, but he could feel it. A silent, heavy stone tumbling through the vacuum carrying secrets from another star. It was a ghost. That is what he decided to call it in his mind. A ghost that had walked past the billion-dollar walls. He reached for his thermos and poured a cup of tea. Steam rose up, curling into the night air. He took a sip, waiting for the emails to start flying, waiting for the phone to ring, waiting for the panic that was sure to follow. For now, it was just him and the ghost. The watchman of Crimea had one last quiet moment before the world woke up and realized how blind it had really been. The story of that morning begins in the quiet pre-dawn hours of August 30, 2019. It was a time when the world was asleep, but in the Crimean Peninsula, Gennady Borisov was wide awake. He was standing in his personal observatory, a small structure that looked nothing like the giant dome-shaped buildings usually associated with professional astronomy. The air was cool and the sky was transitioning from the deep black of night to the faint grey of approaching morning. This specific time of day is crucial to the story. It is the time just before sunrise, a dangerous and difficult window for observing the stars, but it was exactly where Borisov liked to hunt. On this particular date, Borisov was doing what he had done for years. He was pointing his telescope low on the horizon, very close to the sun. He was scanning the sky, looking for movement among the fixed stars. Suddenly on his computer screen he noticed a tiny smudge. It was faint, barely visible against the background noise of the universe. To an ordinary person it would have looked like a piece of dust on the monitor or a digital error. But Borisov knew better. He saw that the object was moving and more importantly it looked fuzzy. In the language of astronomers, a sharp point of light is usually an asteroid, a dry rock. A fuzzy point of light is a comet, an icy body releasing gas and dust as it gets warm. Borisov quickly realized that this object was moving incredibly fast. He took several images and sent the data to the Minor Planet Center, the global organization that tracks objects in space. As astronomers around the world began to calculate the path of this object, they were shocked. Most comets circle the sun in an oval shape like a race car going around a track. This object, however, was not moving in a loop. It was moving in a straight line that would cut through our solar system and never return. The mathematical value that describes this shape is called eccentricity. A perfect circle is 0. A very stretched oval is close to 1. This object had an eccentricity of roughly 3.4. This number was impossible for a local object. It meant only one thing: the traveller had come from deep interstellar space from another star system entirely. It was named 2I Borisov, the second interstellar object ever discovered, and the first one found by an amateur astronomer. To truly understand why this moment was so shocking, we must look at the Goliath that Borisov was competing against. In the modern age, astronomy is no longer dominated by humans looking through eyepieces. It is the age of the machine. We have massive automated systems like Pan-STARRS in Hawaii or the Zwicky Transient Facility in California. These are the giants. They are funded with millions of dollars and operated by large teams of professional scientists. These automated systems are like giant robotic vacuum cleaners for the sky. Every single night they automatically scan huge sections of the heavens. They take thousands of pictures, and powerful computers use complex algorithms to compare the images. If a dot of light moves, the computer flags it. These machines are efficient, they are tireless, and they do not need to sleep. In the last 20 years, these systems have discovered nearly all of the new comets and asteroids. They have turned discovery into an industrial process. The romantic image of the lone astronomer shivering in the cold seemed to be a thing of the past. The machines were supposed to have won. Comparing Borisov's equipment to these dish giants highlights the absurdity of the situation. The professional telescopes have mirrors that are meters wide, backed by supercomputers. Borisov was using a telescope he built himself in his garage. It had a mirror that was only 0.65 meters wide. He designed the tube using carbon fiber to keep it light and stable. He polished the lenses with his own hands. It was a masterpiece of personal engineering, but compared to the Zwicky Transient Facility, it was like comparing a handmade bicycle to a Ferrari. And yet the bicycle won the race. This brings us to the statistical impossibility of the event. The odds of a single human beating the entire global network of automated robots are staggering. It is not just about the size of the telescope, it is about the coverage. The automated systems cover thousands of square degrees of sky every night. Statistically, a machine should have seen the comet first. The fact that Borisov found it suggests something very important about the limitations of technology. The machines have a weakness. Because they are expensive and sensitive, they cannot look too close to the sun. The bright light of dawn or dusk can damage their sensors, and the obvious background light makes it hard for their algorithms to process the data. They are programmed to look in the safe, dark areas of the sky high overhead. Borisov, however, was a human. He could take risks. He intentionally pointed his homemade telescope into the twilight zone, the area close to the horizon just before the sun came up. He was fishing in waters where the big ships could not go. When we talk about the significance of this discovery, we must address the idea of luck. It is easy to say that Borisov just got lucky, that he happened to be looking at the right spot at the right time. But in the world of science, doing something once might be luck. Doing it repeatedly is skill. Before he discovered this interstellar visitor, Gennady Borisov had already discovered 7 other comets and several asteroids. To find one comet is a lifetime achievement for an amateur. To find 7 is extraordinary. But to find the first active interstellar comet in history, beating every supercomputer on Earth, is statistically mind-blowing. If we look at the probability, it is like winning the lottery, but not just winning it once. It is like winning the lottery after you have already won 7 smaller prizes in the same year. This consistency proves that his success was not an accident. It was the result of extreme observation. It was the result of knowing his instrument perfectly and understanding the sky better than the algorithms did. The computers look for patterns they are programmed to find. They look for things that move in ways they expect. Borisov was looking with human curiosity, ready to see something that did not fit the rules. The discovery of 2I Borisov serves as a powerful reminder in our digital age. We often assume that artificial intelligence and automation will replace human effort entirely. We assume that because the machines are faster and bigger, they are better at everything. But this story proves that there is still a frontier that belongs to the dedicated human. The machines are great at processing volume, but they lack intuition. They lack the ability to take the risk of pointing a sensitive lens at the rising sun just to see what might be hiding in the glare. In the end, the David of this story did not defeat Goliath with a stone, but with patience. The machines were asleep, waiting for the safe darkness of the next night. The amateur was awake, watching the dangerous light of dawn. This event proved that in the vast, dark ocean of space, there are still treasures that can only be found by the human eye, proving that passion and persistence can still outmatch raw computing power. To understand why 3i Atlas was such a terrifying anomaly, we must first appreciate the comfort of the ordinary. As the scientific community scrambled to make sense of the dark visitor, the universe provided us with a perfectly timed gift. It offered us a mirror, a standard against which we could measure the madness. That gift was C225 V1 Borisov, introducing C225 V1 Borisov in the chaotic months following the detection of Atlas sky surveys picked up another object. This one, however, did not set off alarm bells. It did not whisper of artificial intelligence or dark physics. It was a comforting, familiar friend. Designated formally as C2025 V1 Borisov, this object was a textbook long-period comet. Its name tells you its story. The C stands for comet. The year is 2025. It was discovered by a standard automated system, though it carries the name of the astronomer who first characterized its orbit. Unlike the strange flat trajectory of Atlas V1, Borisov came from a known address. It hailed from the Oort cloud. Imagine a massive spherical shell surrounding our entire solar system. It is unimaginably far away, thousands of times farther than Earth is from the Sun. This is the Oort cloud. It is the deep freeze of our solar neighborhood, a vast storage locker containing billions of icy leftovers from the formation of the planets. Every now and then, a gravitational nudge from a passing star knocks one of these ice blocks loose and it begins a slow falling dive toward the Sun. That is what V1 Borisov was, a simple block of ancient ice and dust falling inward. It was a visitor from the frozen backyard, not an invader from the unknown. The concept of normal comet physics 101. To truly grasp the weirdness of Atlas, we have to look at V1 Borisov and understand what should happen when an object enters the inner solar system. We need to go back to the basics of comet physics. Think of a comet nucleus as a dirty snowball. It is a mountain of frozen water, frozen carbon dioxide, and frozen ammonia, all mixed with dark gritty dust. While it travels through the deep cold of space, it remains a solid rock. It is dead and silent. But as V1 Borisov crossed the line of Mars and approached the warmth of the Sun, a beautiful physical process began. This process is called sublimation. On Earth, when ice gets warm, it turns into liquid water. But in the vacuum of space, liquids cannot exist easily. So when the Sun's rays hit the surface of the comet, the ice skips the liquid phase entirely. It transforms instantly from a solid block into a gas. Imagine a dry ice machine at a concert. That thick fog is similar to what happens on a comet. As the sunlight strikes the surface, jets of gas erupt from the icy crust. These jets carry dust particles with them. This creates the coma. The coma is a fuzzy, glowing atmosphere that surrounds the solid core. It is a cloud of gas and dust that can grow to be larger than the planet Jupiter, even though the rock inside is only a few kilometers wide. Then there is the tail. This is the most iconic part of a comet. As V1 Borisov dove closer to the heat, the pressure of sunlight itself, and the solar wind, which is a stream of particles flowing from the Sun, began to push against that cloud of gas and dust. Think of it like a person with long hair standing in front of a powerful fan. The hair blows back behind them. In this case, the fan is the Sun and the hair is the gas and dust. This creates a magnificent tail that stretches for millions of kilometers, always pointing away from the Sun. This is what we saw with V1 Borisov. It was performing a perfect, predictable dance. As it got closer to the Sun, it got brighter. We could see the gas venting. We could analyze the light reflecting off it to tell exactly what kind of water was inside. We could calculate its speed, increasing exactly as gravity dictated. The role of V1, the perfect control group. In any good scientific experiment, you need a control. If you are testing a new medicine, you give the medicine to one group of people and a sugar pill to another group. The group with the sugar pill is the control. They show you what happens when nothing changes, so you can compare it to the group where things are changing. S225 V1 Borisov was our control. Its arrival at the same time as 3E Atlas was a stroke of luck. It proved that our instruments were not broken. When astronomers pointed their telescopes at V1, the data was clean. The thermal sensors picked up heat. The spectrometers picked up water vapor and carbon dioxide. The radar bounced off the solid icy surface. The movement of the comet matched Isaac Newton's laws of gravity to the absolute decimal point. V1 confirmed that the laws of physics in our solar system had not suddenly changed. Gravity was still working. The Sun was still hot. Our telescopes were still sharp. The big question. This brings us to this terrifying realization. If C225 V1 Borisov was the normal student who followed every rule, then 3I Atlas was the student who sat silently in the corner, refusing to speak yet moving faster than anyone else. We watched V1 Borisov and we saw the coma explode with light. We saw the tail stretch out across the stars. We saw the speed increase exactly as the Sun pulled on it. Then we looked back at 3I Atlas. Atlas was closer to the Sun than V1. It was subjected to even more intense heat. By all rights, it should have been screaming with gas and dust. It should have had a tail stretching halfway across the sky. It should have been bright enough to see with the naked eye. But Atlas remained a dark, stubborn point. No coma, there was no cloud of gas. No tail, there was no stream of dust. No sublimation. It was not reacting to the heat at all. And yet, as we discussed in the previous section, Atlas was accelerating. V1 Borisov accelerated because of gravity. We could calculate it. Atlas was accelerating more than gravity could explain, but it had no rocket engine and it had no venting gas to push it like a thruster. The comparison between the two objects shattered the skepticism of the scientific community. If V1 proved that our models were correct, then Atlas proved that something was actively violating those models. If V1 was a piece of natural ice behaving naturally, then Atlas was something else entirely. It was a solid dark sabre that ignored the sun's heat but somehow used the sun's presence to move. The control experiment had succeeded. It confirmed that the universe was normal, and by doing so it confirmed that 3i Atlas was undeniably impossibly abnormal. The silence of Atlas was no longer just puzzling, it was now the loudest sound in the solar system. In the vast, silent theatre of our solar system, two distinct visitors took the stage. To understand the strange physics of comets, we must place these two celestial wanderers, Comet C 2013 V1 Boattini and Comet C 2019 Y4. Atlas side by side. This is not just a comparison of data, it is a study of contrasts. It is a story of one object that should have burned but survived, and another that should have frozen but shattered. The tale of two distances. To appreciate this paradox, we first need to look at where these comets were standing in relation to the campfire of our solar system, the Sun. Imagine the solar system as a series of concentric circles. In the centre is the Sun, a roaring inferno of nuclear fusion. The closer you get, the more intense the heat and the gravitational pull become. The fire dancer V1 Boattini Comet V1 was the daredevil of this duo. It followed a trajectory that brought it uncomfortably close to the Sun. In astronomical terms, it reached a perihelion, the point of closest approach that was deep within the inner solar system. At this range, the Sun is not just a bright light in the sky, it is an overwhelming physical force. The radiation hitting V1 was intense enough to boil rock, let alone ice. We can imagine V1 as a dancer stepping directly into the flames. The expectation here was chaos. Scientists expected the ice to sublimate, turn from solid to gas, violently blasting dust and gas into space in a chaotic storm. The ice dance. Atlas, the Atlas Comet. Atlas, on the other hand, was situated much farther away during the period of our observation. It was travelling through a region where space is significantly colder. While V1 was stepping into the fire, Atlas was gliding through the freezer. At this distance, the sun's warmth is gentle. The thermal stress, the shock of heat changing the temperature of the comet's core, should have been minimal. Atlas was effectively walking on a safe flat sidewalk compared to V1's tightrope walk over a volcano. Shutterstock, the paradox of survival. Here lies the central mystery of our study, a contradiction that puzzled observers and delighted astronomers who study the physical composition of comets. Logic dictates a simple rule: stress causes fracture. If you take a ball of ice and dirt, which is essentially what a comet is, and throw it into a furnace, you expect it to crack, pop and sizzle. If you leave that same ball of ice in a refrigerator, you expect it to remain relatively unchanged. However, the universe often ignores our simple logic. The behaviour of V1. Despite being subjected to the fire, Comet V1 behaved with remarkable dignity. It did not explode, it did not crumble, instead it brightened. As it approached the sun, its ices turned to gas in a steady, consistent release. It was like a well-engineered machine. It took the immense solar energy and converted it into a glorious tail and a bright coma, the atmosphere around the core, without losing its structural integrity. It survived the fire. The behaviour of Atlas conversely. Comet Atlas, the ice dancer, fell apart in the safety of the cold. While it was still far from the sun, at a distance where it should have been stiesel, it began to disintegrate. It was not under immense heat pressure yet, it shattered. This is the paradox. Why did the object under extreme torture V1 survive, while the object in the comfort zone Atlas died? This suggests that the dance of ice and fire is not determined by the environment, the sun, but by the internal character of the dancer, the comet's nucleus. V1 was likely a solid, dense, cohesive rock-ice mixture. Atlas, despite its size and initial brightness, was likely a rubble pile, a loose collection of dust and ice held together by nothing more than weak gravity and hope. When the slightest rotation or mild warming occurred, it simply couldn't hold itself together. Reading the light curves. To visualize this dance, astronomers do not just look at photos, they look at light curves. A light curve is a simple graph. The horizontal line represents time and the vertical line represents brightness magnitude, the centro of V1 smoothness. If you look at the light curve of V1, you see a beautiful smooth shape. It looks like a gentle hill or a perfectly drawn arch. As the comet got closer to the Sun, the line went up steadily. As it moved away, the line went down steadily. There are no sudden jerks or jagged edges. This smoothness tells us that the release of gas and dust was uniform. It tells us the surface of the comet was eroding evenly layer by layer, like a bar of soap being used under warm water. The signature of Atlas chaos. The light curve of Atlas looks like the heartbeat of a terrified runner. It is jagged, chaotic, and unpredictable. Instead of a smooth hill, we see sudden spikes where the brightness jumped up, followed by steep cliffs where the brightness plummeted. These spikes represent outbursts. An outburst happens when a massive chunk of the comet breaks off and exposes fresh ice to the sunlight, causing a sudden explosion of gas. The steep drops represent the dust clearing away, leaving behind a smaller broken nucleus. The chaotic nature of Atlas's light curve is literally a graph of its death. We are watching the object crumble in real time through the data, the conclusion of the dance. Comparing these two objects changes how we view comets. We often think of comets as identical dirty snowballs, but V1 and Atlas prove that no two are alike. V1 was the stoic survivor. It proved that a comet can withstand the fire of the sun if its internal structure is sound. It obeyed the mathematical laws of brightness almost perfectly. Atlas was the fragile giant. It proved that size and initial brightness are not guarantees of survival. Even in the ice of the outer solar system, a comet with a weak-heart nucleus can destroy itself through rotation or minor structural failure. In this cosmic dance, V1 moved with the grace of a professional handling the heat with elegance. Atlas stumbled and fell before the music even reached its climax, proving that in space, internal strength matters far more than external conditions. When astronomers first realized that 3I Atlas was not staying in a fixed orbit, but was actually moving through our solar system from deep space, the immediate assumption was that it must be a comet. This is a logical assumption because almost everything that falls into our neighborhood, from the icy outer edges of space, is a comet. We expected it to behave like a dirty snowball. When a comet gets close to the sun, the intense heat causes the frozen water and gases on its surface to boil instantly. This process, called sublimation, turns ice directly into gas. This gas expands violently and drags dust particles off the surface of the comet. This cloud of gas and dust is what creates the coma, the fuzzy atmosphere around the center, and the iconic tail that stretches out for millions of kilometers reflecting sunlight. However, when telescopes were pointed at 3I Atlas, they saw absolutely nothing of the sort. This was the first impossible observation. Despite passing closer to the Sun than the planet Mercury, 3I Atlas remained a perfectly clean, sharp point of light. Even the Spitzer Space Telescope, which looks for heat signatures and infrared light, could not detect any dust or gas. If 3I Atlas were a normal icy rock, it should have been screaming with evaporating steam. The silence was deafening. It meant that 3I Atlas was either made of stone and metal with absolutely no water, or it was something entirely different that we had never seen before. It was a dead rock walking through the fire without sweating a drop. Non-gravitational acceleration, the invisible push. If the lack of a tail was strange, the way 3I Atlas moved was frighteningly unexplainable. In space, the movement of celestial bodies is dictated by gravity. It is the law of the cosmos. The sun pulls an object in and the object swings around it in a precise calculable curve. We can predict exactly where a rock will be 10 years from now based on gravity alone. But 3I Atlas broke this law. As it moved away from the sun, astronomers noticed that the object was deviating from its expected path. It was not just drifting, it was speeding up. It was moving faster than the gravity of the sun and the planets could account for. In physics, we call this non-gravitational acceleration. To understand this, imagine you are rolling a bowling ball down a perfectly smooth hill. Gravity pulls the ball down and you know exactly how fast it should go. But suddenly, halfway down the hill, the ball starts moving faster than gravity should allow. It is as if a tiny invisible hand is pushing it from behind. For a standard comet, this invisible hand is easily explained. Remember the tail we discussed. When a comet shoots gas out of its surface to form a tail, that gas acts exactly like the exhaust from a rocket engine. The gas shoots one way and this comet is pushed the other way. This is the rocket effect. But here is the problem. We already established that 3I Atlas had no tail. It had no gas. It had no dust. There was no visible exhaust. Yet it was accelerating as if it had an engine. It was being pushed by a force we could not see, amounting to a deviation of thousands of kilometers from where it should have been. Some scientists suggested it was being pushed by the pressure of sunlight itself, a concept known as a solar sail. But for that to work, the object would have to be incredibly thin, like a sheet of paper, which rarely happens in nature. The invisible push remains the single most controversial aspect of the object's visit. The core contradiction V1 versus Atlas. To truly appreciate how weird 3I Atlas was, we must compare it to its sibling, the object we call V1. V1 appeared shortly after Atlas, and it was exactly what astronomers expected an interstellar visitor to look like. V1 was comforting, it made sense. V1 had a massive glowing tail. It was fuzzy and surrounded by a cloud of gas. Because it was venting gas, it experienced a slight rocket push, but this was perfectly consistent with the amount of gas it was releasing. V1 followed the rules of physics that we understand. It was an icy rock, it got hot, it melted, and the melting pushed it slightly off course. Atlas, however, was a paradox. Think of V1 as a steamboat. You can see the smoke, the tail, so you are not surprised that it is moving forward. The cause, smoke, and the effect movement are visible. Now think of 3I Atlas as a rowboat that is suddenly moving as fast as a speedboat, but there is no engine, no oars, and no wake in the water. Atlas displayed the movement of a comet, the acceleration, but the appearance of an asteroid, no tail. In nature, you generally do not get one without the other. An asteroid does not accelerate because it has no fuel to burn. A comet accelerates because it burns fuel, but you can always see the smoke. Atlas was moving with the agility of a powered craft while looking like a dormant stone. This contradiction is what led some serious scientists to whisper the word artificial. If nature cannot explain the push, perhaps technology can. Colour, strange spectral changes. Finally, we come to the visual identity of the object, its colour. In astronomy, colour is not just about aesthetics, it tells us what an object is made of. We determine this by analysing the spectrum of light reflecting off the surface. V1, our control group, was stable. It looked the same no matter when we looked at it. It had the standard reddish hue of an object that has been floating in deep space for millions of years. Cosmic radiation usually burns the surface of organic rich ice, turning it dark red. 3 Atlas, on the other hand, was a chameleon. As 3I Atlas tumbled through space, flipping end over end, rather than spinning smoothly, its colour seemed to shift dramatically. Telescopes observed it oscillating between a deep dark red and a more neutral, sometimes even greenish or bluish hue. Red typically indicates dead organic material or iron-rich rock similar to the asteroids in our own system. But the shift toward green or blue is baffling. In the context of comets, green usually comes from specific gases, like cyanogen or diatomic carbon glowing in the sunlight. But we already know Atlas had no gas cloud, so why the colour change? One theory is that the object was shaped like a long cigar or a pancake. As it tumbled, we were seeing different sides of it. Perhaps one side was cooked red by cosmic radiation, while the other side had been freshly broken off or scraped clean, revealing the blue material underneath. Another more exotic possibility relates to the metal hypothesis. If the object were made of highly reflective metal, the colour shifts might not be the surface changing, but rather the way sunlight reflects off a shiny, tumbling surface at different angles. Imagine a shiny car spinning in the air. Sometimes it looks silver, sometimes it reflects the blue sky, sometimes the dark ground. While V1 was a consistent, predictable fuzzy red ball, 3I Atlas was a flickering, tumbling, colour-shifting riddle. It refused to be categorised, changing its appearance as if it were trying to hide its true nature from our lenses. Every time we thought we understood it, the light changed and the mystery deepened. As we moved into the second half of the year, the feeling in the air shifted from scientific curiosity to a palpable heavy tension. It wasn't just one thing that caused this unease, it was the way everything seemed to stack up one unlikely event on top of another until the pile became too high to ignore. We call this the convergence. It is the moment when distinct, unrelated lines of history and physics suddenly cross at a single glowing point in the sky. To understand why the world began to hold its breath, we have to look at the relentless drumbeat of events that occurred between midsummer and the end of the year. The timeline of late 2025 reads less like a scientific log and more like the script of a slow-motion thriller. It started in July. The heatwaves were breaking records across the northern hemisphere, but the heat inside the astronomical community was of a different kind. This was the month of confirmation. Telescopes in Chile and Hawaii finally agreed on the trajectory of V1. Until July, there was a hope that perhaps the initial calculations were wrong, that it was just a trick of the light or a glitch in the sensors. But July stole that hope. The data confirmed that V1 was not tumbling randomly like a normal asteroid. It was stable, too stable. By August, the narrative changed. As V1 crossed the orbit of Mars, it didn't speed up exactly as gravity dictated. It made a subtle, almost imperceptible adjustment. We aren't talking about a sharp turn, but a course correction of roughly 0.03 degrees. In the vastness of space that is tiny, but for a rock it is impossible. Rocks do not steer. This was the moment the word artificial started moving from the fringe forums to the university cafeterias. September brought the other player onto the stage, Comet Atlas. As the comet began to brighten, showing its magnificent tail, astronomers realized that V1 was matching its pace. It was no longer just falling toward the sun, it was shadowing the comet. Imagine two cars on a highway where one speeds up just enough to stay in the blind spot of the other. That was the dynamic. October was the month of confusion. This is when the amateur astronomers started losing track of V1. It wasn't because the object disappeared, but because its albedo or surface reflectiveness seemed to drop. It went dark as if someone had dimmed the lights. Then came November, the month of the leak. A grainy image supposedly from a military satellite circulated online showing V1 not as a cigar shape but as something with a structured metallic glint. And finally December. By the end of the year, the object was visible to the naked eye, a faint, unblinking red dot sitting uncomfortably close to the brilliant smear of Comet Atlas. But the timeline is only half the story. The true strangeness lies in the geometry of space. When we talk about the position of V1, we are not just talking about distance, we are talking about lines of sight. In three-dimensional space, the odds of a random asteroid parking itself directly on the observation corridor between Earth and another major celestial body are astronomical. Yet that is exactly where V1 settled. Picture a straight line drawn from the center of the Earth to the nucleus of Comet Atlas. For a period of 3 weeks, V1 stayed within 4,000 kilometers of that invisible line. It was sitting in the front row. From the perspective of Earth, V1 was perfectly framed against the backdrop of the comet's tail. If this was a coincidence, it was the equivalent of throwing a dart from New York and hitting a specific coin in London. This specific geometric alignment suggested that V1 wasn't just travelling, it was observing. It was positioned in a way that allowed it to see the comet up close while simultaneously maintaining a direct line of communication or observation back to Earth. It was a triangulated position that maximised data collection from both targets. This precise geometry opened the door for the boldest hypothesis of all, one that reignited a debate from nearly 50 years ago. The conversation inevitably turned to Professor Avi Loeb and the search for extraterrestrial technology. Loeb and his colleagues pointed out a detail that sent shivers through the community. They looked at the celestial coordinates. When astronomers traced the origin path of V1 backward, projecting where it had come from before entering our solar system, the line pointed to a very specific region in the Sagittarius constellation. This region is famous for one thing: the WOW signal. In 1977, a radio telescope picked up a strong narrowband radio signal that lasted 72 seconds. It was unique, powerful, and never repeated. It became the most famous candidate for an alien transmission in history. The frequency was 1420 MHz, the frequency of hydrogen, which is considered the universal language of physics. The hypothesis put forward in late 2025 was staggering. What if the WOW signal wasn't just a hello? What if it was a launch notification? The math was terrifyingly plausible. If a probe were launched from that region of space shortly before the signal arrived in 1977, travelling at a high fraction of the speed of light or using gravity assists, we don't yet understand the timing of its arrival. Roughly 50 years later fits the window. The WOW signal might have been the doorbell ringing and V1 was the guest finally stepping onto the porch. The coordinates were too perfect. It turned the history of SETI's search for extraterrestrial intelligence upside down. We had been listening for a second radio call, but perhaps we should have been looking for a physical arrival. Under the weight of these realizations, the impossible timeline, the deliberate geometry, and the historical connection the institutions we rely on for answers began to act strangely. This brings us to the atmosphere of rumours and silence. Usually when NASA or the European Space Agency makes a discovery, there is a rush to publish. Press conferences are scheduled, papers are uploaded to preprint servers, but in the late autumn of 2025, the opposite happened. The flow of information dried up. It started with small delays. The James Webb Space Telescope had been scheduled to do a deep field scan of the V1 object in October. The public schedule listed the observation, but when the date came, the images were not released. The official statement cited calibration errors and processing delays. This happened 3 times in a row. Then came the closed-door meetings. Flight logs showed that the heads of major space agencies along with several high-ranking military officials flew to Geneva in November. The official story was a summit on space debris and satellite safety. But you don't send 4-star generals to talk about old rocket parts. The silence was not absolute, which made it worse. It was leaky. We heard stories from university researchers who said their grant funding was suddenly put on hold pending security reviews. We heard whispers of astronomers being asked to sign non-disclosure agreements that were far stricter than standard industry practice. The tone of these rumours wasn't necessarily malicious. It didn't feel like a cover-up of a crime. It felt like panic. It felt like the people in charge were staring at a screen, seeing data that defied their understanding of the universe and simply not knowing what to say to the public. How do you announce that a rock is watching us? How do you tell the world that a signal from 1977 has finally come home? The neutral observer might say they were just being cautious, waiting for peer review. But to the rest of us watching the skies as December approached, the silence spoke louder than any siren. It was the quiet of a room right before the glass shatters. The narrative of 3i Atlas has moved beyond mere discovery and orbital calculation. We are now entering the most critical phase of this cosmic encounter. As the calendar turns and the weeks dissolve into days, a palpable sense of tension is building within the global scientific community. We are no longer just watching a dot on a screen, we are preparing for a rendezvous with history. The period we are entering is not just a viewing window, it is a fleeting high-stakes test of our technology, our patience and our ability to understand a visitor from beyond our solar system. The countdown to December 19th. As we move relentlessly toward the 19th of December, we are approaching the climax of this celestial event. This date marks the perihelion, the moment when 3i Atlas reaches its closest point to the Sun. For an object composed of ancient ices and dust, this is a trial by fire. Imagine a traveller accustomed to the absolute zero temperatures of deep interstellar space suddenly plunging toward a roaring furnace. As 3i Atlas dives toward this point of maximum proximity, its speed will increase dramatically, driven by the immense gravitational pull of our star. This specific date is not just a mark on a calendar, it represents a gravitational slingshot. The object will swing around the Sun subjected to intense tidal forces. These are the invisible hands of gravity that will pull and stretch the body of the comet. Scientists are watching this date with bated breath because this is when the object is most vulnerable. The heat from the Sun will penetrate the outer crust of 3i Atlas, causing the frozen gases inside likely carbon monoxide, nitrogen and water ice to sublimate instantly. This means they will turn directly from a solid into a gas, skipping the liquid phase entirely. This violent transformation is what we call outgassing. It is a chaotic, explosive process. Jets of gas will erupt from the surface, acting like natural thrusters that can slightly alter the comet's trajectory. The 19th of December is the ultimate stress test. Will 3i Atlas survive this close pass? Or will the thermal shock and gravitational stress tear it apart, leaving us with nothing but a cloud of fading debris? This question drives the urgency of the current moment. The great unveiling, what are we waiting for? As the distance closes, the wait is not passive. It is an active search for specific phenomena that will reveal the true nature of this interstellar wanderer. We are looking for 3 distinct signatures. The formation of the tail. First and foremost is the visual evolution of the object. To date, 3i Atlas has appeared mostly as a compact point of light. However, as the heat intensifies, we expect the formation of the coma, a fuzzy atmosphere of gas and dust surrounding the core. Following this, we anticipate the growth of the tails, yes, tails in plural. We are waiting to see if an ion tail emerges. This would be a stream of electrically charged gas particles blown straight back away from the Sun by the solar wind. It often glows with a spectral blue hue. Simultaneously, we are looking for the dust tail, which is heavier and curves gently along the object's path. The composition of these tails is the key. If the dust tail is thick and bright, it suggests 3i Atlas is rich in heavy materials, perhaps metals or silicates from a planetary system very different from our own. the fluctuation of brightness. Secondly, we are monitoring the object's light curve. In simple terms, this is a graph of how bright the object appears over time. Comets are notoriously unpredictable. They're often described by astronomers as being like cats. They have tails, and they do precisely what they want. We are waiting for a potential outburst. This is a sudden dramatic increase in brightness, potentially caused by a massive chunk of the surface breaking off or a fresh pocket of highly volatile ice being exposed to sunlight. Such an event would turn 3i Atlas from a telescopic object into something visible to the naked eye or binoculars. Conversely, a sudden drop in brightness could indicate the object has disintegrated. Every shift in luminosity tells a story about the structure and density of the nucleus. The search for a signal. Perhaps the most intriguing aspect of this wait falls into the realm of non-visual astronomy. Major radio telescope arrays are pointing their massive dishes toward the coordinates of 3i Atlas. They are not necessarily listening for messages in a science fiction sense, but rather for radio waves emitted by specific molecules. When complex molecules break down in sunlight, they emit radio frequencies that act like a fingerprint. By analysing these signals, we can determine the chemical recipe of the object. Is it made of the same stuff as our local comets? Or does it contain exotic ratios of carbon and oxygen that are impossible to form in our solar system? Furthermore, there is the remote scientific curiosity regarding any anomalous signals, narrow-band radio emissions that cannot be explained by the natural outgassing. While the likelihood is infinitesimally small, the 3i designation marking it as an interstellar intruder compels us to listen for anything that suggests this object is not just a passive rock but something artificial. The European Space Agency's golden ticket. While observers on the ground watch and wait, the European Space Agency (ESA) finds itself in a unique position to act. This is the scenario space agencies have dreamed of since the discovery of the first interstellar object, Oumuamua. In the past, we were too slow. By the time we realised an interstellar object was here, it was already leaving. But with 3i Atlas, we have a rare luxury warning time: the probe strategy. The ESA has been developing concepts like the Comet Interceptor, a mission designed for exactly this moment. The strategy relies on having a probe already parked in space waiting in a stable orbit, known as a Lagrange point. Rather than building a rocket from scratch, which takes years, the agency can activate a waiting spacecraft. The opportunity here is not to land on 3i Atlas, then the speeds are far too high for that. The object is moving at tens of thousands of kilometers per hour relative to Earth. Instead, the goal is a kinetic flyby. The probe would be directed to intersect the path of 3i Atlas, touching the remnants. The most ambitious goal of this maneuver is to touch the environment of the comet without physical contact with the nucleus. As 3i Atlas sheds dust and gas, it leaves a trail of breadcrumbs behind it. The ESA probe is equipped with dust counters and mass spectrometers. By flying through the tail, the wake of the comet, the probe can physically sample the material. This is archaeology at thousands of miles per hour. By catching these dust grains, the probe analyzes the building blocks of a distant star system. It is a chance to touch a piece of a world that existed billions of years ago, light years away. The data sent back would be the first direct analysis of physical material from outside our solar system since the Stardust mission returned samples from a local comet, but with infinitely higher stakes. The role of the community, a call to the stars. Finally, the window of opportunity is not exclusive to billion-dollar space agencies. There is a vital, irreplaceable role for the citizen scientist. Professional telescopes like the Hubble or the James Webb Space Telescope have a very narrow field of view. They are like looking through a drinking straw. They can see great detail, but they cannot look everywhere at once. Furthermore, their time is booked years in advance. This leaves a massive gap in the data, a gap that amateur astronomers are perfectly positioned to fill. The army of observers. We are calling upon the global network of backyard astronomers. These are the dedicated individuals with telescopes set up on patios in gardens and on rooftops. Their contribution is quantity and continuity. While a professional observatory might track 3i Atlas for an hour, the global community can track it 24 hours a day. As the sun rises in Europe, observers in the Americas begin their watch. As the Americas sleep, Asia and Australia take over. Why this matters? If 3i Atlas fragments, or if it has a sudden outburst of brightness, it will likely be an amateur astronomer who sees it first. History is filled with major discoveries made by people simply looking up with passion and patience. The data collected by amateurs, photos, brightness estimate, and trajectory checks is often uploaded to central databases used by NASA and the ESA to refine their models. We are asking enthusiasts to document the shape of the coma and the length of the tail night after night. We need a continuous, unbroken record of this object's journey. This is a democratization of science. You do not need a doctorate to contribute. You only need a clear sky, a decent optic, and the dedication to stand out in the cold looking for a faint smear of light that has travelled for millions of years to visit us. The shared experience of beyond the data, there is a philosophical importance to this community effort. 3i Atlas is a reminder of our shared place in the universe. When thousands of people across different continents and speaking different languages all point their instruments at the same coordinate in the sky, it creates a unifying human moment. We are all looking at the same visitor, sharing the same sense of wonder. As December approaches, the window is opening. The stage is set. The physics are in motion. All that remains is for us to watch, to measure, and to witness the secrets that 3i Atlas is about to reveal. So we have arrived at the end of our long journey through the stars. We have travelled billions of kilometres in our minds following the path of a frozen wanderer known as Comet C 2025 V1 Borisov. We have looked at its ice, its dust, and its lonely path from the edge of the solar system. Now, as the night deepens and the noise of the world fades away, it is time to ask one final question. Why does this comet matter? Why did we spend all this time talking about a rock that is by all accounts quite ordinary? The answer is hidden in that very word, ordinary. In the exciting world of movies and science fiction, we are always looking for the strange and the shocking. We want to find aliens or portals to other dimensions, or objects that break the laws of physics. We want the loud explosions and the dramatic twists, but in the quiet, patient world of real science, there is nothing more valuable than something that is perfectly beautifully normal. Think about it this way. Imagine you are a doctor. To understand when a patient is sick, you first need to know exactly what a healthy person looks like. You need to know the normal rhythm of a heart before you can hear a problem. You need to know the normal temperature of the body before you can detect a fever. Without a baseline of what is normal, you cannot understand what is special. That is the gift of Comet C25V1. It is our cosmic baseline. For years, astronomers have stared into the darkness, wondering what the building blocks of our solar system really look like. This comet is a time capsule. It has been preserved in the deep freeze of the Oort cloud for 4.5 billion years. It has not been melted by the sun before. It has not been smashed by other rocks. It is pristine. When we looked at this gas coming off this comet, we saw the usual recipe. We saw water vapour, we saw carbon monoxide, we saw simple dust. It behaved exactly as our computer models predicted. It brightened when it got close to the heat and it faded as it moved away. It did not tumble wildly, it did not speed up unexpectedly like the strange object Oumuamua did a few years ago. Because C25V1 is so boring, it confirms that we are on the right track. It tells us that our theories about how the solar system formed are correct. It proves that the chemistry that created the Earth and eventually created you and me is common and widespread. It is a comforting thought. It means that the universe follows rules. It means that nature is not chaotic but organised and elegant. This brings us to a deeper philosophy. Science is often taught as a collection of facts. We learn that the speed of light is roughly 300,000 kilometers per second. We learn that water is H2O. We memorize these answers and think that is what science is. But the story of this comet reminds us that science is not really about the answers. It is about the courage to ask the questions when you do not know the answer. It takes a special kind of bravery to look up at the infinite black sky and say, I do not know what is out there, but I am going to look anyway. There is a beauty in the unknown. We used to be terrified of comets. In ancient times, people thought they were bad omens or messages from angry gods. They feared the streak of light in the sky. But through patience, observation and reason, we turned that fear into understanding. We replaced the monsters with mathematics. We replaced the terror with wonder. Comet C225 V1 Borisov reminds us that it is okay to be small. It is a mountain of ice flying through a solar system that is millions of times bigger than itself, which is part of a galaxy that is billions of times bigger than that. And yet we, with our tiny eyes and our short lives, can understand it. We can measure its speed. We can list its ingredients. We can predict where it will be 1,000 years from now. That is the triumph of the human mind. We may be small, but our understanding is limitless. Now the show is over. The comet has finished its close performance near the sun. It is already moving away from us. Every second that passes, it travels kilometers further into the dark. It is heading back to the freezing cold lands where it came from, far beyond the orbit of Neptune, far beyond the reach of the sun's warmth. It will not return for thousands, perhaps millions of years. It will become a silent frozen statue once again drifting in the great cathedral of space. It will float in the silence between the stars where there is no sound, no wind, and no time. And as it drifts away, it leaves us here safe on our blue planet. Take a moment now to let that sink in. The comet is out there rushing through the void, but you are here. You are warm. You are safe. The ground beneath you is solid. The gravity of the Earth holds you in a gentle embrace like a heavy blanket pulling you down into comfort. Imagine you are standing in a wide open field at night. The grass is cool and soft under your feet. The air is fresh and still. Above you, the sky is a vast dome of velvet black scattered with the diamond dust of a billion stars. Somewhere in that vastness, our comet is saying goodbye. It is fading into the shadows, its tail disappearing like a wisp of smoke. It has done its job, it has told us its secrets. Now it rests, and you should rest. The universe is a busy place filled with burning stars and spinning galaxies, but it is also a place of immense peace. For every star that explodes, there are endless light years of quiet, empty space. That silence is not empty, it is peaceful. It is the silence of a library, or a sleeping house, or a deep ocean. Let your mind connect with that cosmic quiet. Let the worries of your day drift away just like the dust from the comet drifts away into the solar wind. They are small. They are temporary. You are part of something much larger, something steady and slow and ancient. Breathe in the night. Breathe out the tension. The stars will still be there tomorrow. The planets will keep spinning in their perfect circles. The comets will keep sailing through the dark. Everything is working exactly as it should. There is nothing you need to solve right now. There is nothing you need to fix. The story is finished. The book is closed. The sky is watching over you. As you close your eyes, imagine the soft, pale light of the comet fading, fading, fading into the distance until it is just a tiny speck, and then nothing, just the gentle, comforting dark. Good night, traveller. Sleep well.